The session. Yeah.
Yes, sir.
So, so I'm starting. Very good morning to our August audience and our eminent guests to this fourth day of this online ISCF project phase 2 5-day faculty development program on application of artificial intelligence and machine learning in security. Today, we are honored to have with us Dr. Rajendra Pamula, Assistant Professor in the Department of Computer Science and Engineering, Indian Institute of Technology, ISM Dhanbad. A very warm welcome and heartfelt thanks to you, sir, for joining us today.
Thank you.
Before we begin, let me take this opportunity to introduce our eminent speaker, Dr. Pamula. Dr. Rajendra Pamula received BTech in Computer Science and Engineering from Jawaharlal Nehru Technological University, Hyderabad, Andhra Pradesh in 2001, and MTech in Computer Science and Engineering from Andhra University, Visakhapatnam in 2004. He received his PhD from Indian Institute of Technology, Guwahati, Assam in 2015. At present, he is working as an assistant professor in the Department of Computer Science and Engineering, Indian Institute of Technology, ISM Dhanbad. His areas of interest include data mining, machine learning, and computer networks. He has published 14 reputed ACI journals, 30 international conference papers, and he has guided 2 PhD students. So may I now request you, sir, to enlighten us with your speech on machine learning and security.
Yes, thank you. Thank you for the introduction, and thank you for the privilege that you have given to me for talking on this topic. I'll just share my slides. Can you see my slides?
Yes, sir. It is
Yeah.
Clearly
Yeah.
visible.
Yes.
Uh, So I want to talk on machine learning and security. Maybe you might be expecting that I'll be talking on the research problems and majority and how we use machine learning and security. Don't get confused. Uh, so I'll be just talking like what is the relationship between machine learning and security, and why we use machine learning. Uh, what is the scope of machine learning, where we can use in the security. That is the broad talk of my presentation. I'll be relating the security and machine learning very much. I'll be not talking about uh, the core problems or techniques used in the security as much. So I'll just give an understanding of why we have to use machine learning and why we have to use in the security and how they are related. There are so many questions sort of a thing. I just want to put these questions in front of you, and it may help you in understanding the research problems and research understanding where we can work on it, and where is the scopes that we have it. That is the idea of the talk. Okay, so we start with, I just want to start with the quotes the great people have given, the breakthrough, a few quotes which will help you to understand what exactly why we have to use machine learning and things like that. The breakthrough in machine learning would be worth 10 times Microsoft's. This was given by Chairman Bill Gates. At present, he's not there, but still, the quote is valid. He says, like the 10 times Microsoft. And the second one, which is machine learning is the next internet. Tony Tether, a director of DARPA, has given like, he's saying that machine learning is the next internet. We understand that when the internet was initially launched, so the technology has been completely changed. We are now, when we think back last 10, 20 years back, the things are different, and now the things are different. Everything, everyone, a layman who doesn't understand anything about internet is also using internet. So that is the way, the path that is going to lead to us. And here we have another thing is that machine learning is the hot new thing. And Ton Hennessy, President Stanford, he was talking about what exactly it is very odd, and which is new thing, which is really deeping into different areas where we can understand how the machine learning works. So now here, like another one is web ranking today are mostly a matter of machine learning. So we rank webs, we want everything to be ranked, whether it is the a professor capability or whether a student capability, everything is in terms of ranks. And all we have ranking in web rankings, the net, the pages, everything, whether you like it or not like it, everything is ranked. That is given by web rankings today are mostly a matter of machine learning. Prabhakar Raghavan, a director research, Yahoo. Machine learning is going to result in a real revolution. Gad Papadopoulos, CTO son. These are the few quotations which are given by the very popular and famous people who are dedicated in research and development. Uh, so with this, I want to just start with, we all know that Google now is dominating everywhere. Wherever you see the Google is the one. So I taken this definition from Google. What does Google say about the machine learning? What is the meaning of machine learning in terms of Google definition? So machine learning is a type of artificial intelligence that provides computers with ability to learn without being explicitly programmed. So it has an ability to learn, and learning is the one where people say, like in general terms, we call it as every teacher is a learner, every student is a learner, every person is a learner. So what we understand here is that a machine learns by itself is one of the greatest capability that can be programmed. So a machine which can learn is the one which can rule. That is the main thing that we can understand from this particular definition. Machine learning focus on development of computer programs that can teach themselves to grow and change when exposed to new data. So if I give a book to a child or a kid, what he does, he try to do whatever he may tear the page, he may find out some images, he may go to a last page, or he may he may put some water on the book, whatever it may be. What he is trying, this is the process of learning. So what we see here is that machine learning makes things to learn. See, that is how the development started. If there is a learning inside in it, we can understand that we can understand more things more better way. So what is machine learning? In a different terms, a branch of artificial intelligence concerned with design and development of algorithms that allow computers to evolve behavior based on empirical data. We have a data, and we have to predict, we need to assume, we need to analyze, we need to develop, we need to understand, we need to uh, recommend. These are the things that we understand. As intelligence requires knowledge, it is necessary for computers to acquire knowledge. So the knowledge is the main thing, and the data is main thing. We need to acquire knowledge, and we need to have a knowledge. And the computers, given some artificial intelligence, they will learn by itself. So, see, the question starts from here. So, what is machine learning? A simple way is a simple way to present it or put it here: automatic automation. Automatic automation. Uh, Getting computers to program themselves. Writing software is the bottleneck. Let the data do work instead. So these four steps makes what is a machine learning. How I am saying this one is like, See, we are actually trying to program the things in terms of a machine learning. And this machine learning, what I am trying to do is like, these programs learn by itself. It will train itself. It will develop itself. Okay. The computers to program themselves. That means like it will adjust itself. So that is the idea. And what is our core thing? That is what we call it as a data. So someone who doesn't have data, we cannot do anything. So the main thing is the data, that which will help you to write some programs, and those programs will automatically help you to learn the machine. Traditional programming, what we see is like a data and a program is given to a computer and an output is given out. This is a simple traditional method where we see. What is a machine learning? A data is there, an output is there. We have a data and we want this output, and the computer does a program. This is the idea of a machine learning. So we have here like the idea of putting simply, it's moving. Yeah. So learning system model. We have a learning system model where we have an input samples. We have a system which will be trained, and then we'll get a learning method. And on the learning method, we test it, we get the output. That is the simple idea. So here we have another thing, like we call it as training and testing. So without training, we cannot develop a system. A simple way is like, if you want to train your children, the best way you train them comes from the data that we are going to, the facilities that you are going to provide them. How are you training the children? The similar way, the training part is very, very important to make the system learn. Training is the process of making the system able to learn. So in order to learn better way, a unprivileged person and a privileged person, what is the difference? It's only a training. There is nothing more than that. The gap between a privileged and unprivileged person is a training. A training, how do you train them? The better the training you make it, he will learn more things. No free lunch rule. This is a simple training set and a testing set come from the same distribution. So we assume that if you don't have a training, you don't have a lunch, and the training cost incurs some cost, and that means we don't have lunch. If you don't work, you don't get training. Need to make some assumptions or bias. That means like some assumptions are made in order to make the distribution and testing set properly. See, the performance of any particular person is impacted by training. There are several factors affecting the performance. If I am doing better, there are certain factors which I am getting affected. If I am not doing better, then some other factors are affecting me. What are the effects that are there in order to increase my performance? Any performance, a system. Here you're talking about a mission which we is learning. If it is not able to learn, what are the factors that is affecting? So the types of training provided. Simple first question is like, what sort of a training you have given to the mission? The form and an extent of any initial background knowledge. Anything which we have to give to a system, what is the initial background of that particular person? I'm not saying is this thing like, if you want to hire a faculty member, what we are trying to see? We are trying to see what is his background, where he is from, what is his publications, what is his projects. That is what we are seeing. We are seeing, trying to find out the background. Similarly, performance of any mission is based on initial background, the type of feedback provided. So once you are training, the coach is giving the feedback. Oh, this is where you have to improve. This is where you have to develop. That type of a feedback we are going to provide. And finally, the skill, that is what we call it as learning algorithms. The skill. You may give a best coach to your kid, best coach to make him learn. Maybe I am giving an example of a live example, White Hat Junior. You may think that, okay, White Hat Junior is giving an advertisement saying that this is the best coding platform available. If a kid is not interested, how best platform, how best feedback you give, how best background you give, it doesn't matter. Maybe he learns, but the main core point is the learning algorithms. The algorithm that we going to develop is the core point. If the kid he doesn't accept it, the kid is not able to accept the things, then the proper performance will not come out. These are the factors which will be affecting. The two important factors, that is modeling and optimization. So the learning algorithms can be modeled properly and then can be optimized. So optimization, you all know, and the modeling techniques that we all know. So coming to now here, that algorithms, the main core part, the success of machine learning system also depends on algorithms. Obviously, without algorithm, we cannot make anything success. The algorithms control the search to find and build the knowledge structure. So, maybe I can give you an example like PV Sindhu, who is a shuttle badminton player. See, her father has given her a best training and coaching where she has built up. Why he has become the top world-class player? Only because the control, the search to find out, build the knowledge structures. That means like only his desire, her desire in building up her knowledge structures. How to play in the court, how to do the things. So I am talking about here, I am making you to understand with real practical application with respect to mission development, mission learning algorithms. The learning algorithms should extract useful information from training examples. The learning algorithm should extract useful information from training examples. That means like you have to train yourself. We have to train ourselves. The mission has to train so that we can develop a best learning algorithms. So as we all know, algorithms are divided into supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. We all know that. We are not discussing about this thing in depth. This is not a course sort of it. This is a lecture which talks about why machine learning, why security, what is the relationship between them, what way we can improve machine learning algorithms in order to improve the security. That is the main idea. So machine learning structure, we all know supervised learning. We have here like the training documents, images, and we have feature vectors. That means the documents are on whatever it may be. The inputted data is converted into feature vectors, and these feature vectors are given to develop the machine learning algorithm. And whereas these are the supervised because their labels are given, and using these labels and features we develop the machine learning algorithm, and that is what we call it as a predictive model. And once the test case comes, we try to expect the label. And whereas in unsupervised learning, I'm not going in depth and just giving an idea. So here also, here only difference between unsupervised and supervised, we don't have labels. We have the features, we have the machine learning development model, and we have the likelihood or better representation where the data point belongs to. So coming to now machine learning and security. So now question is, why machine learning and security? Can machine learning techniques solve our computer security problems? The question that I am putting in front of, can the machine learning techniques solve our computer security problems? People are right now thinking like, yes, machine learning can do anything. Put an end to cat mouse game between the attackers and defenders. Can machine learning put an end to the cat and mouse game? This cat and mouse game will be there for the life. Wherever we are, there is attackers, and we have to defend. So this problem will be there. Then Tom and Jerry, you all know, like this is the same thing for Tom and Jerry, cat mouse. Is this a merely for hype? The question is like, all machine learning techniques solve the computer security problems, whether this is a hope or a hype. So we look at whether it is a hope or a hype. So we understand that a threat detection reference model architecture based on ML. So this is a simple architecture which will talks about security aspect, that is threat detection based on ML. So we have here data sensing. We take the data, we do the pre-processing, we extract features, that is the feature vector which I have told you. And so once that is there, we try to detect real-time detection. Features are detected in real time, and the model is being developed. Okay, detection model. Machine learning algorithm is used to develop a detection model, and finally we give the model to the detection and we extract, and a summary will be given in the form of an attacks and the humanities. Whether all attacks which are come out from the machine learning architecture based model, whatever the prescribed attacks are, not only the attacks which are being developed, there may be an errors in the machine learning techniques. So continuing machine learning and security, we see that machine learning is eating the world. Everywhere, every institute, every department, even the business, all medical, everywhere we see that everyone talks about machine learning. People talk about machine learning, from communications and finance to transportation, manufacturing, and even agriculture. Nearly every technology field has been transformed by machine learning and artificial intelligence, and will be soon, and it will be. So then computer security, if you talk about computer security, is also eating the world. So why I'm talking about why this is eating a world, the term why we are using this word, everyone is eating this particular technology. Everyone says like, I have used this technique and to prevent this one. I have used this technique to develop this one. I have used this one to manufacture this one. It is right and it is good, but why? What way we can do it? As we become dependent on computers for an ever greater portion of our work. So nowadays we are without computer, no life, no system, no life. And we are forcing and we are depending, we are making habit of our younger generations also to be habituated. It is good, but entertainment and even entertainment also we have to have a security. Social lives, we have to have the security. The value of breaching these systems increases proportionality. So machine learning and security, there is a breach between them, and that is increasing proportionality, where we need to have a breach between them. drawing in an increasing pool of attackers. The attackers are very common, very normal. It's sometimes feel like I was surprised to hear a news in the article, in one article, news article, where they are saying like graduate people who are not having jobs, who are not having uh, uh, any work to do, they are using their knowledge in hacking. Hackers are growing. Hackers are going because money is one of the important factor which makes things rule. Hackers hoping to make money or simply wreak mischief. Sometimes it can be a mischief. Sometimes, majority of times, it is intention hacking. Furthermore, as systems become increasingly complex and interconnected, we all know that every time we are connected. Is there anyone who is not connected in 24 hours? In 24 hours, most of the time, we are connected. Younger generation are also connected. The one who has to do, they are connected because they have to do their job. They are connected. But the younger generations are connected. Furthermore, as systems become increasingly complex and interconnected, we all see that it becomes harder and harder to ensure that there is no bugs or no backdoor that will give attackers a way in. I don't know whether to say this one or not. Nowadays, who is the right one? Right one means a good person or a bad person will not be able to know. Who he lives with you in your surroundings very commonly and very normally, and after certain time he tried to find out a chance to um, uh, uh, break your door. That is the what happening. We don't know whom to trust and whom to believe. No bugs. And when we are connected everywhere, we have the same problem. So in beginning there was a spam. Academics and scientists have hooked enough computers together via internet to create a communication network that provided value. Initially, the network was created to provide the value, and then started a spam. Other people realized that this medium of free transmission. Who are the other people? They felt that this is the free transmission, broadcast distribution was a perfect way to advertise sketchy products, steal account credentials, and spread computer virus. So I give you one more example. I was actually last year I was ordering some cake in my hometown. I belongs to Andhra Pradesh, and I was ordering a cake in the cake to my one of my dear ones in the online. I paid and my credit card says that the transaction has been completed. Your amount was detected. And what was the company that were they say the cake that from which I have ordered? They were saying like, sir, we have not received the money. So I tried maybe some error would have been happened. I thought like whether I'll go for one more time, and then I did the transaction one more time. 999 plus 999, two times it was detected from my credit card. So then I got a doubt like they were trying to cheat me. Then I understood. Then immediately I called the main head of the company, the bakers then. And then I told him that the two transactions I have made it, and the people in the office where they are saying that your transaction is not over. So then then they responded me. So no. I have found that your transaction is done. I'll check it out. I think I'll check. Then when he cross-checked, verified, the two transactions were complete. The shop members who are working in that shop, they are intentionally trying to cheat. So everywhere you find the people where will be the chance to cheat. So you see, like a medium of free transmission and broad distribution was perfect way to advertise sketchy projects, steal credentials and spread computer viruses. So these people are there and we have to be very careful. So now here, like in coming to, in intervening 40 years, the field of computer and network security has come to an MCAP and around range of threats and domains. There is a wide range of threats and domains. Intrusion detection. I think you people are all security people. You know better than me, like security detection, web application security, malware analysis, social network security, and advanced precision threats. Just name a few. I just named a few things. There are much more. I was worrying so many things, surprising to see things about these things. So now the story of spam fighting servers as a representative example for the use of data and machine learning in any field of computer security. We all understand that there is in every field spam fighting. We need to understand that. Malicious actors can pose security risk to almost all aspects of modern life. There are so many actors which pose security risks. We call one peculiar word which is there in general English, which is called a hypocrite. No, I am very sorry to say that I am uh, living a life of hypocrite. Really speaking, if one person comes, we will try to adapt our system and behavior basing on his attitude. I am trying to hide my real character. Everyone, everywhere, trying to pretend what he is not. Really trying to project ourselves as an hypocrite. And similarly, the malicious actors can pose security risk to almost all aspects of modern life. The fundamental nature of battle between attacker and defender is same in all fields of computer security as it is in spam filtering. Simple spam filtering in case defender and attacker, the same war is there existing everywhere. You cannot avoid this. And a motivated advisory is constantly trying to misuse a computer system, and each side races to fix and exploit flaws in design and technique before other uncovers it. So we have to motivate, advise. What does he try? He tried to misuse the computer system, and each side races to fix it. We'll try to fix it, and someone try to misuse. Again, we try to fix it. We try to, and this is what we call it as design fault. We have to uncover it. The problem statement has not changed one bit. Even one bit, it is not changed. The problem is cat and mouse. The problem is Tom and Jerry. The cat and defender and attack. Their problem has not even changed a bit. There is a misuse and we need to solve it. How to defend, how to protect. That is how we see. So we see here, like in this the cyber threat landscape, in a general landscape, that where we have threats, the landscape of adversaries and miscreants in the computer security has evolved over time, but general categories of threats have remained the same. The threats are same, the style is same. Security research exists to stymie the goals of attackers, and it is always important to have a good understanding of different types of attacks. Uh, uh, I'm sorry. Yeah, security research exists to stymie the goals of the attackers, and it is always important to have a good understanding of different types of attack that exist in the wild. So the research people right now, you people are working in a different research areas, in security research areas. You people have a challenge everywhere, trying to find out what is the best way to detect the best attack. Not best attack, how attacks can be detected. So this is all, you all know the taxonomy that is been given here: information gathering, uh, intrusion attempts, fraud, abusive content, malware, and availability attacks. There are certain classifications. I find it very interesting in these slides where you have been classified with a different category. That is why I put here. It was very interesting. See now here, like why the attacks happens. Why the attack happens? What is the driving force behind this attacks? So this is what talks about what drives attackers to do what they do. The one thing, as I was saying, the cash economy, direct monetary gains. Recently, I have seen one kid who has addicted to drugs. So he was trying to cheat other people. What is the main thing? He doesn't see like whether he is a relative or whether he is a close neighbor. Doesn't matter anything. What is his main motive is like he want monetary gain. Money, money, money. The motivation of cyber attacks today is largely monetary. Everywhere the power is money. Money is power. People say that. But the thing is like the motivation or which drives behind the attacker is what we call it and money. Attacks on I was thinking to give like how many number of attacks in the survey has been found, that what is the rapid growth of attackers for only money. But I thought like it was not very much good to project all the wrong things here. Attacks on financial institutes can obviously bring attackers direct financial gains. We have a direction because they have a direct financial gain. They have money. They have because of the allure of more direct path to financial aid. The marketplace for vulnerability targeting such institutions is also comparatively crowded and noisy. It is not easy to attack any of the system, and it is noisy and it is crowded, but people want because they have a direct money. They want that money. Real world uses machine learning in security. Yeah, uh, applying machine learning and data science to solve problems is not straightforward task. Obviously that is true. People say like using any machine learning techniques is not as straightforward as we think. It has to be modified, it has to be appropriated, it has to be classified, it has to be differentiated based on a data or requirement on applications. How this can has to be done? We can classify machine learning use cases in security into two broad categories. So I am not talking about a wide range of classification. I am just talking about two very basic classifications: pattern recognition and anomaly detection. They are quite good different. Sometimes they also are also overlapping each other. The line differentiating pattern recognition and anomaly detection is sometimes blurry. Yeah, that is what I'm saying. It's overlapping sometimes, but each task has clearly distinguished goal. Pattern recognition, we all know like what is a pattern recognition. Discover explicit or latent characteristics hidden in the data. We have data and the data contains certain characteristics that no need to specify. These are the explicit characteristics. These characteristics, when distilled, that means when filtered into feature sets, can be used to teach an algorithm to recognize other forms of data and exhibit the same set of characteristics. That means if you have some data, once you try to analyze certain features, we get better features in terms of the same features which have been filtered. That is what we understand. The patterns extracted from pattern recognition must be strictly derived from observed data used to train the algorithm. That is the condition that we have to maintain. Any pattern which we have extracted must be strictly derived from the observed data. That means like we cannot say that this is not extracted from this particular. The chances of predicting this one should not be wrong. So anomaly detection in other way, other classification, which is a knowledge discovery in anomaly detection, the other side of the same coin, where we also try to extract knowledge and information features. Here also we are extracting another thing. But what is the difference between instead learning specific patterns that exist within certain subsets of data, the goal is to establish a notion of normality. That means given a data, you have to understand that certain data are normal, certain data are abnormal, and which are abnormal, which are deviating from the normal data, is generally very minute in number, very small in number. That is why normal data are 95% and remaining abnormal data are maybe 5% or less than that. Therefore, deviations from this normality of any sort will detect as anomalies. Detect as anomalies. So here now comes like, if you understand machine learning and what we need machine learning in terms of security, and can machine learning solve all the problems of the security, and if the machine learning can be used, what are the sub classifications like pattern recognition and anomaly detection, and if at all we use these techniques, what will be the limitations of machine learning in security? See, the first one we see is the notion that machine learning methods will always give good results. People, any student right now, if you ask, they are doing all projects in machine learning. They are saying like, I am using the machine learning techniques. I am using machine learning techniques. Thus, it gives a good results every time across different use cases in categorically false. This is not my definition. This is the this is the statement given by majority of machine learning teachers, scientists. The notion that machine learning methods will always give good results across different use cases is categorically false. It's categorically false. It can be considerably more difficult to extract the reasons for a decision made by the machine learning systems compared to a simple rule. Sometimes we'll not be able to understand why it is coming like that. We do the result analysis, we develop a model basing on certain data, and you found out that sometimes it is giving some other solution other than which we are not able to understand why it is coming like that, why that reaction is going on that way. Nobody understanding. Like, so right now we are having COVID. We are not able to understand why this is not getting stopped. What is the problem? How to do it? People are worried. People are struggling to develop a medicine, vaccine. The same thing, it is more difficult to extract reasons for a decision made by the machine learning system compared to the simple role. Jovially, I am saying like the COVID is generated by a machine learning technique. Everyone understands that this is a man-made, what you call it as man-made virus. Everyone accepting this is a man-made virus. But whether this man-made virus is made by a machine learning technique, there is no silver bullet machine learning algorithm that works well across all problem spaces. You cannot say that this is a silver bullet. And across all spaces, we cannot use machine learning. The human decision-making process is informed by a vast variety of contexts drawn from cultural and experimental knowledge. This process is very difficult for machine learning system to emulate. This process is very difficult for machine learning system to emulate. Is it possible like a man's experience and machine's experience, or man learning and machine learning, can we relate? Never. Never. Maybe you have seen the movie called Robo, Rajnikant movie. There, what we see is like the feelings have been incorporated in the mission. It's not true. It's not real as we see in the movie, as we understand things in the movie. It's not true. Machine learning problems and approaches. Suppose that you are in charge of computer security. I'm talking about in terms of small terms of security only. You install firewalls, hold phishing training, ensure secure coding practices, and much more. And you have made all precautions to develop a computer security system. You take it upon yourself to build systems that can detect, block malicious traffic to any attack surface. So you are confident enough that I have made a system using a machine learning techniques, and I have shown to your boss. Ultimately, these systems must decide the following. Yes or no? For every file sent through the network, does it contain malware? For every login attempt, has the someone password been compromised? For every email received, is it a phishing attempt? For every request you to your servers, is it a denial of service attack? For every outbound request from your network, is it a bot calling its command and control server? These tasks are all classification tasks. So what we see here is like, once you want to develop a system which will be protecting system, what is the main thing is like we have to do simple classification, whether it contains a malware or not, whether he is compromised with the password, whether he has a phishing attempt or not, whether a denial of service here, all are classification, binary classification. Binary classification. About the nature of observant event. Your job, just rephrase. What is our job rephrase? You are security, taking care of security development system. And what is our now? Classify all events in your network as malicious or legitimate. We are actually trying to see that whether the network which we are going to give is malicious or legitimate. That means like entire thing is simply made into a binary classification. That is what we call it as anomaly detection. Detecting unexpected events and anomalies in the systems. That means like we need to make sure, based on classification techniques, whether we have to use the classification technique. Yes, in the context of network and host security, anomaly detection refers to identifying unexpected intruders or breaches. On average, it takes tens of days of a system breach to be detected. If someone has accessed your system, in order to find out a breach, whether there is a breach or not, you have to take 10 days or more. After an attacker gains entry, however, the damage is usually done in few days or less. Maybe you can understand more clearly, like the things that are available. Sometimes it happens like we don't know that we are got attacked. We have been attacked, and we'll be understanding only after certain times. The importance of anomaly detection is not confined to the context of security only, and it can be used in very wide applications. In more general context, anomaly detection in any method of finding events that do not conform to expectation. So anomaly detection, we understand that this can be used on security, and the security contains not only anomaly detections is restricted to security, and it can be used in wide range of applications. A grid, a power grid, we can initial failures, system failures when make a total shutdown of the grid, power grid. And you all can also used in the fraud detection, insurance fraud or financial fraud. Initial thing, like we can not only limit it to the security aspect, we can use on other hand, there is an important distinction between outlier detection and novelty detection. These outlier detection and novelty detections are comes under anomaly detection. But what is novelty detection is like uh, they are regular data models. The task of novelty detection involves learning a representation of regular data using data that does not contain any outlier. That means what we understand here is like the data which we are talking about, it doesn't contain any outliers. It contains only a regular data. It contains only a regular data. The task of outlier detection involves learning from data that contains both regular and outlier. So novelty, can we have an example of novelty detection? So all our cricket players, one is very efficient player. That is what we call it as novelty detection. Very good football player, and the one who is very good at football is the novelty detection. And what is an outlier detection? An outlier detection is a detection where we have normal data as well as abnormal data. That means like mischief. All people are very good in studying, but one person is very mischief. Extreme case. That is what we call it as anomaly detection or outlier detection. Both can be called as an anomaly detection, but specifically we have outlier detection. So, and this anomaly detection, yeah. So anomaly detection can be used in time series. So as we all know, like a time series data, this is very prominent nowadays. And we also call this time series data in terms of stream data. The study of anomaly detections is closely coupled with the concept of time series. Yes, with because an anomaly is often defined as a deviation from what is normal or expected. Even time series data, when we see like we have a normal data and an abnormal data. So the time series is a sequence of data points of events. So a simple example, I'll give you a time series data, ECG graph, and we may not be understanding what are the readings of ECG graph, but the doctor can understand. He can understand what is abnormality and what is normal. What is abnormality and what is normal. These data points often collected at regular intervals constitute a sequence of discrete metrics that categorize changes in the series as time progresses. Okay, example is stock market over time, and we have a bash commands entered into a command line. So initial this time series and anomaly detection comes under the area of intrusion detection, and you people are working on intrusion detection, but with heuristics. What I'm talking about is heuristics in the sense like we have to pre-specify some of the assumptions. Even today, using thresholds and heuristics and simple statistical profile remains a reliable way of detecting intrusions and anomalies. Although threshold-based anomaly detection logic is easy to implement, some questions quickly arise. What are these? So I want to tell you, like, because of these heuristic techniques, can we make it into a more what you call it as more self-learning based techniques? That is the main intuition we want to say. Okay, how do we set the threshold? Could some user require a higher threshold than others? Could there be times when users legitimately need to access the database more often? How frequently do we need to update the threshold? Could the attacker exfiltrate data by taking over many user accounts, thus requiring a smaller number of access per account? See, these are the questions, very general questions, which we use when we use about intrusion detections with heuristics. The statement says here like machine learning can help us to avoid having to come up with answers to all these questions. That means like, can we set up a threshold? Yes. With the help of machine learning, we can set up a threshold. We can train the system and we can find out a value where optimal value is selected. And could we see that higher threshold than others? So where we have to increase the threshold, where we have to decrease the threshold, how do we can do this? Yes, using machine learning, we can do it. And is the some legitimate users can give more access to the database? Yes, the privileged people can be given more access to the database. Instead of letting the data define the solution to the problem, machine learning can be used to detect these questions. A set of objectives of an optimal anomaly system. So we see that machine learning in security can be described in terms of anomaly detection, and anomaly detection can be used in terms of time series. That is what we call it as intrusion detection. In terms of data moving from one place to another, we try to talk in terms of intrusion detection. And so we have that these are the objectives of an anomaly detection system. So low false positives and false negatives. So generally we should have that, say suppose for example, a test is detected positive, say suppose COVID is detected positive, but he doesn't have COVID. We should not accept these things. We should not accept a test is detected positive, but he is not having the disease. He is not acceptable at all. And the anomaly detection system must take care of these particular things. We should have low false positive, because we cannot avoid completely this error, misclassification error, but we can reduce the number. The one which reduces the number of false positive can increase the credibility of your algorithm. Similarly, false negative. If a test was negative and whereas you are detected positive, it is not right. Easy to configure, whereas the algorithms or systems that we need to develop is, it should be easy to configure and tune and maintain. Whenever you want to tune, whenever you want to modify, whenever you want to change the parameters, you have to have that flexibility. We have to maintain that flexibility. The system need to be maintained. Immediately we have to configure, adapt to the changes, trends in the data. We adapt to the changes and trends to the data. That means whenever the system changes, say suppose for example, our authority asks one data at one time, another one who asks another time another data, and we have to mold ourselves. And the same way we are actually trying to change our trends. So works well across the data sets of different nature. Okay, we need to make sure that our methods which we are going to develop should work on different nature of data. Resource efficient and suitable for real time applications. Okay, uh, we should be consider that it should be resource efficient. Okay, what are the different sources that we are getting, and what are we are having resources, using that it should develop a real application, real-time application or real-time algorithm which will able to find out anomalies in the system. And sometimes it should have that explainable letter, as I was saying, like why. If someone asks like why, we need to make sure that the algorithm should explain that why we have done that. What is the reason why this is coming like this? Why it is been predicted like this? You all know what is an intrusion detection system. An intrusion detection system is a wall of defense to confront the attacks of the computer systems on the internet. The main assumptions, I will not talk about anything about intrusion detections, or I will not talk about cyber security. I will not talk about these things. I will be talking about why we are going to use, why machine learning is important. The main assumption of intrusion detection system is that behavior of intrusions is different from legal users. The main assumptions of IDS is that the behavior of intruders is different from legal users. The types of anomalies, you all know that intrusion detection system, anomaly approaches, and misuse and signature detection approach. Determine whether the deviations from normal usage patterns can be flagged as intrusions. So this is the anomaly approaches. And whereas misuse or signature based methods, the kind of approach uses patterns of well-known attacks to identify intrusion. That means we know before, we know, understand that these are available. So the main purpose of using, we are not talking about signature based, we are talking about anomaly approaches. Clearly machine learning is well suited for the first kind of approach. What is that first kind? To determine whether the deviation from normal usage patterns can be flagged as intrusions. That means the system learns by use itself by making a machine learning algorithm whether there is a deviation from the normal usage pattern and whether we can call it as an intrusion. That knowledge will be developed using the machine learning. So I'm just giving a small example where this k nearest neighborhood classifier is being used to in machine learning, in intrusion detection. See this paper, use of k nearest neighbor classifier for intrusion detection. Though they have used k-nearest. That means every machine learning algorithm can be used for detecting some anomalies inside the data, some intruders. I'm talking about here intruder, some anomalies in the. So what does this do? The k means what does it do? It uses classification model, whether to a normal or an intrusion. And what it will do, the program behavior is represented by frequencies of system calls. Each system call is treated as a word, and the collection of system calls over each program executed as a document. So what they have done this thing. That means like every system call is being used as a word, and these words are being categorized in the form of a document. Whether this word is present in the document or not there. How do we calculate? Basing k nearest neighbor classifier. Okay, the categories. So the method seems to offer more computational advantages over those that seek categorized program behavior with short sequences of system calls and generate individual program profiles. So instead of making it individual program profiles, it is better to use KNN classifier, and it helps you in the form of a text categorization. And another one is support vector vision, which is well-known classifier. So this is been also used in a new intrusion detection system using support vector vision and the hierarchical cluster. You all know what are the hierarchical clustering and what is the support vector missions. So that means like what I want to tell you is like using uh, uh, using machine learning techniques, we can easily tell you whether there is a intrusion in the system or not. And the decision tree, another important classifier, a decision tree. This is based on the decision tree, subset of sequences, and which takes the decision at every node. And this is what we see. This is what we call decision tree classifier for neural intrusion detection with GA-based feature selection. That means what they did, they have selected certain features using genetic algorithm, and what they have done, they have used a decision tree classifier on the feature set, on the feature selection, and then they have classified whether there is an intrusion or not. This is published in some conference. And another important classifier is what you call ensembling classifiers. This is one improving performance. It's this technique is what we call it as performance improvement classifiers. We call it as ensembling classifiers, and the combination of multiple weak learners. That means we try to combine more classifiers into one to get the better approach. The learners are trained on different samples to improve the overall performance. To combine the outputs of weak learners, the most common techniques are majority rule. Say suppose for example, I find that um, mm, I take three classifiers, and I do the classification on subsets of data, and then I found that the classification on the test tuple is based on majority rule. That means like the classifier which classifies the right class is what you call it as majority class. That which classifier classifies the data sample into the right class is what we call it as majority rule. We all know boosting and bagging. Bagging is like divided into subset of bags, and then what we do is like we try to apply on different bags a different classifier, and finally we try to get the classification. Boosting is also something subset we calculate, and we apply more data and then boost upon the classifier. So this is the some example where we can see that TCP packets and connection records, feature extraction, network features. We have different features, intrinsic features, traffic features, and content features and classification. So ensembling methods which will help you in multiple classifier system, where different classifier 1, classifier K, classifier K2, and so on. Like if you have different classifiers, we do, and the decision is based on the ensemble. That is decision fusion function, whether it is normal class or an observer. That means instead of using a specific classifier, we are trying to do it on multiple classifiers, and we are combining the results based on the majority vote uh, techniques or bagging or boosting technique. You see here, like this is the one of the paper which has been accepted. Fusion of multiple classifier for intrusion detection in computer networks. Multiple classifier. So now here, like coming to the conclusion of challenges of using machine learning techniques in anomaly detection. The costs of errors in intrusion or anomaly detection is huge. The cost of errors in intrusion or anomaly detection is huge. Yes. Misclassification of one anomaly can cause crippling breach in the system. As I was saying, like giving an example of COVID patient, COVID, the test is positive. The COVID is positive. The test, that means rapid test, is positive, but he doesn't have COVID, which creates panic, which creates insecurity. So misclassification of one anomaly can cause crippling breach in the system. This is very, very important. Raising false positive alerts has a less drastic impact, but spurious false positive can quickly degrade confidence in the system. If two tests fails, COVID test fails, right now we are facing this pandemic. So if you face the 2 tests or 10 tests fails, what is the situation of the people who got this test? Because of the high cost of classification errors, fully automated endless anomaly detection systems that are powered purely by machine learning are very rare. So we need to make sure that we have to develop a machine learning in such a way that it is a fully automated end-to-end anomaly detection system, and which gives is the right classification. Sometimes be difficult to explain why an event was flagged as an anomaly, leading to a longer incidence of investigation cycles. So rapid test होने के बाद what rapid antigen test will be done. After that, what they will do another test, which will take 3 to 4 days to get the result. Till then, the person will be put into quarantine. So this is the importance of machine learning techniques. Will create we create will create what do you call it as a panic in the system. So applications in machine learning techniques, we all know that appropriate web content which we have here is like inappropriate web content, drive-by attacks, uh, malicious JavaScript and other scripts, actual attacks, phishing attacks, reputation, and these are some of the machine learning applications where we can use machine learning techniques. These the people are using, and people are working on different machine learning techniques applied onto the security to restrict these things. As we see here, as we see here, uh, inappropriate content, basically just document classification. Want to stop bad sites contents, we good classifier can be Navy's Bayesian or a multinomial or a multi mixture model. These have a problems in practice. Add IR techniques such as term frequency, invert document frequency, and we use support vector mission approaches. Okay. All right. Okay. Malicious JavaScript also, where the normal document classification works on the presence of words in the files. It also possible, whereas in the JavaScripts, what we have to do is that we have to find out the similar methods in the similar script and extract words. Though all we won't extract all the words, other features of interest and feed on this model. Okay. Here, malicious malicious non-executable files. We have here like but there is a lot of file formats out there. I'm sorry. Uh, uh, it's not feasible to figure out the formats for all. It is not feasible to figure out the formats for all these files themselves. So we have to write an application that can learn a file format. In the case of zero-day attacks, we have no data to compare against. So we can't just create and train simple binary classification. So the final stage of an attack is downloading an executable. Okay, typically blocked using signatures, effectively quite advanced regular expressions. Viruses writes now releases several variations of their viruses over its lifetime, and release viruses that can cause themselves appropriate that can change themselves as they propagate. See now here like we have a malicious executable files. This all makes a signature based approaches increasingly infeasible. uh, F-Secure now checks every file against 5 lakh signatures, and McAfee now checks a file. Just just 1 minute. Yeah. Okay. Okay. I'm sorry. Really, this all makes signature-based approaches increasingly infeasible. The rate at which the variants of viruses come out in growth rapidly. Vendors are struggling to develop a techniques to detect variants using their existing technologies. Best continue to add separate signatures for each new variant is not feasible. So if they try to develop a new variants, and for every variant you have to give a new signature is very difficult. So that is not feasible also. That is what it says like. So we need to seek investigate machine learning techniques to look into this. So how does a machine learning techniques helps in malicious executable files? So several approaches has been used in the past, that is like binary classifiers using existing virus samples, Techniques include decision trees, self-organizing maps, Navy's vision classifier. And these techniques are all used in order to give best way to find out a malicious executable files from the different solutions. Okay. Um, so coming to another important problem with security is malware. We all know like what is a malware, and malicious software is a software designed to infiltrate or damage a computer system with owners informed consent. Okay, viruses infecting and worms propagating, Trojan horses inviting, and we all know all these things, these terms, spyware, commercial. So now here, like, there is a battle between the malware and defenses. So whether machine learning techniques can be incorporated in order to develop malware protection or malware defenses. That is what we see. We can see that a malware development can be done into four major categories: encryption, polymorphism, and metamorphism, and obfuscation defenses. We have scanner, emulator, and heuristics. So these are the only differences which are actually existing in the malware detection techniques. But whether machine learning can be used, if there are different variants, how the machine learning techniques can be applied onto so that we can better get the malware classification. So that is the main idea. Okay, malicious software is classified into families, each family originating from a single source based on exhibiting a set of consistent behaviors. We have a static analysis and running runtime analysis. Okay. We work on different emulators where machine learning techniques are applied in the static analysis and runtime analysis. Okay. Now coming to finally adversarial machine learning. So what we see is adversarial machine learning. Um, what we understand from adversarial machine learning is like any effect or attempts to fool the machine learning techniques so that it will give you a wrong result. This is called adversarial effect or adversarial machine learning. So I was looking at one particular article where it says like, say suppose an image which contains a bird, simple intruder, what he does is that he'll simply change some features of the image, and that image is now classified into a hammer. One image is a bird, some bird, and that is classified into a bird when initial machine learning technique is then applied, and later on after applying some adversarial effect on the image, what machine learning does is that it will classify wrongly. This is what we call it as adversarial effect on machine learning. Okay. Technique that attempts to fool the models by supplying deceptive input. Some deceptive input will be given, so that what happens is that machine learning will give you wrong impression. It will give you a wrong classification, wrong prediction, wrong model thing. The most common reasons is to cause malfunction in machine learning is model malfunction. Okay. So the adversarial machine learning, we have a key vulnerabilities of machine learning systems. So if a system knows that the model derives from fixed data, that means every time the machine learning and things, so simple and key vulnerabilities where if you change the fixed data sets, then what happens is that there is a vulnerability. And assuming similar distributions of data and the real world data. Strong adversarial in machine learning, and that means like aware of usage, reverse engineering machine learning systems, adaptive aversion, and temporal with the training model. That means these are the strong adversaries. That means you know about everything about the machine learning. We know about everything about the machine learning. Right, see, what we see here is like practical adversarial attacks, where what are the practical constraints for adversaries. That means how do you restrict our attack on machine learning, how do you constrain how effective the adversarial attacks impact on the machine learning. So these are the very important things that we have to look into it. So another important context in adversarial effect is what we call it as malicious crowdsourcing. Okay, the context here is crowdsourcing. So you all know what is a crowdsourcing. It is a new threat, malicious crowdsourcing, which is also called as a crowd turfing, hiring a large army of real users for malicious attack. So nowadays, if you can understand, um, we can understand, like, if you want to propagate a wrong information, we hire some people. We hire some people and we'll say that, okay, this is the right one, or this is a good source of what you call it as good source of techniques that been used. Okay, so like that, hiring a large army of real users for malicious attack. That means you are trying to say that the attack is correct. That means saying that you simply saying, like, if you want to buy uh, any TV, say suppose if you want to buy a TV, what you are trying to take the feedback of certain people. So if you take 100 people feedback, if they want to intend that, if you want to get motivated that you want to buy a wrong product, we can do that by making the impression, trying to deviate your psychology. And like this, like what I want to tell you is, like, malicious attacks can be done using the real users. That is what we call it as crowdsourcing. Fake customer review. So generally, if you nowadays all things are online and we depend upon customer reviews, and you find it like some of the fake reviews are there. The product is not, but we get reviews. Sometimes we get rumors, targeted spam. That means, like, people target people, certain people. Most existing defenses fail against real users. Okay. Uh, Here, what here is that Samsung was fined for paying people to criticize HTC products. So what was the Samsung doing in October 24 2013? Samsung was fined for paying people, because it is paying people to criticize HTC products. That is what we call it as crowd turfing. Shady Craigslist ads offer cash for fake Yelp reviews. That means if you give wrong fake reviews, they give money. Mechanical turkey, unsavory side effect, massive spam generation. There is a side effect, and which is a spam which is generated very massively. It is been generated. Vietnam admits deployment of bloggers to support government. So government here, we what is that? Vietnam is they have separated, deployed some bloggers. They will tell they support like anything, whatever the Vietnam does. They say that whether it is right or wrong, they say that it is good. Republicans use crowdsourcing to attack Obama campaign. These are the things where we find it the malicious attacks on different data. So we understand the crowd trafficking aims to gain or destroy reputation of people products, and other entities through spreading biased opinions and framed information. So we try to give some biased opinions. Oh, we don't know, we don't know anything, but we try to give some opinions. We don't know the real picture about that one, but we give opinions. This is right, this is wrong. That is the main problem where we have to see. And this crowd trafficking detection, this is one of the security important problem in social forums. Crowd trafficking detection is the process of detecting crowd trafficking activities with software systems. The detection method can be unsupervised through discovering the anomalous traffic or on basis of pattern of a historical crowd trafficking activities. So this is very popular in social media. It is the crowd trafficking activities that regard social networking platform as a main information channel of the campaign. Crowd trafficking workers use social media accounts to spread information and may result in unfair popularity such as hacked trending topic in social networks. So this is what happening. Which is right news, which is wrong news. This is a simple classification technique. But the reviews that you give, the feedback that you give is affecting more on our technology. We also get most of the information, and that information, whether it is true or not, nobody knows. Have you ever saw in YouTube like how to reduce weight in YouTube, how to control our diabetes, how to see the BP control, what things you eat, things. How many videos you will find? So many videos. Which is right, which is wrong, nobody knows. What is the reviews? You see the reviews down. You see that majority of reviews are, some are very good reviews, some are bad reviews. How do we do it? How do we analyze it? This needs in the machine learning. So online crowd trafficking systems services connect customers with online users willing to spam for money. So the main thing is that money. Connecting customers with online users willing to spam for money. So site located across the globe, China, US, India, where we have these online crowd trafficking systems. They are workers, they work hard, and they are being targeted on different what you call it as a different social media. And crowd trafficking in China, we have the largest crowd trafficking sites in China is the Jubilee and $1 million industry. This is a $1 million industry. How do we stop this crowd trafficking? Simple methods usually fail. How do we understand that this is the right person? The machine learning, more sophisticated modeling on user behavior. We need to analyze the user behavior, and then we understand that for what reason he has come here. And you are how to click. The user behavior can be analyzed using how you click. Perfect context to study adversarial machine learning. Highly adaptive workers seeking invasion. Crowd turfing site admins tamper with worker behavior. See here, they are trying to capture the site indicates that they are trying to evade your network. So the goals and questions here in this crowd trafficking is like develop a defense against crowd trafficking, understand the impact of adversarial countermeasures and the robustness of machine learning algorithm. Key questions: what machine learning algorithms can accurately detect crowd trafficking workers? What are the possible ways of adversaries to evade classifiers? Can adversaries attack machine learning models by tampering with training data? See, these are the three important, very important questions which helps you to understand whether machine learning algorithms accurately detect crowd trafficking workers. Who are crowd trafficking workers? The real users. A normal person who doesn't behave differently for the sake of money, for the sake of his interest. He will give you all sort of wrong reviews. This is a VIBO. VIBO is a Twitter in China. A Twitter in China which talks about evasion attack, and what is that? Another one is poison attack. What is evasion attack? Workers evade classifiers. So what they do is that they evade classifier. That means they are being wrongly classified into, you see here, they are wrongly classified into the real classification. They pretend like real users. They come into, this is called evasion attack. Whereas poison attack is what we call it as crowd trafficking admins tamper with the training data. That means like they tamper the admin, the data, training data. So what was happen? Once the training data has been tampered, the system machine learning algorithm will be tampered. Machine learning will not be able to produce the right classification. That is called the adversarial effect on machine learning. The features to detect crowd workers. Search for a behavioral features to detect workers. So we need to understand the observations of the features of the workers. Final set of useful features. So user interaction, active at pose, but have a less bidirectional interaction. Retweet. That means we are trying to ask them to retweet. We are asking them to give a new profile. Baseline profile. What is the profile of the tweeter? Burstiness of tweeting. Task-driven nature. Whether it is depending upon the task or not. Periodical patterns. That means anything which we are going to use, it is basing on the features, useful features. And we have to see the observations. Then we can develop a new adversarial vision. Individual workers as adversary. The workers itself is the figure in the rightmost corner, right below corner. You see that fox is been dressed up like a sheep. What does it tells you? He is trying to invade. The real worker is invading. Attack strategy depends on workers' knowledge on classifiers. So if you are a weak learner and learning algorithm and the feature space and training, we have a problem. What knowledge is practically available? How does different knowledge level impact workers and evasion? This is about the adversarial effects on the machine learning. So this is what I want to conclude. There are many applications in security that uses machine learning techniques. Machine learning gives the best solutions. Even machine learning techniques can be attacked. So this is what my complete presentation. I hope I just want to, actually the main idea is of my presentation to make the bridge between machine learning and security. And the people who are working on security, you have to learn machine learning techniques in order to develop the best security algorithms. Dr. Professor Santanuji?
Yeah, I'm there. If anyone has any other questions?
Yeah.
Hello.
Yeah,
If
yeah.
anyone had any questions, you can put it into the question answer or in a chat. I think one question has come. So can you please give me an example or algorithm where ML is used for intrusion detection? Sanjay Kumar Pal, he is asking a question.
Yeah, yeah.
So can you give some example or algorithm where machine learning is used for intrusion detection?
Sanjay Pal, actually in the
Yeah.
slides, if you see, like I have seen 3 or 4 algorithms where they have used KNN, decision tree, support vector mission. There they have used in machine learning, and I have cited that papers also. If I can go back.
Sanjay Kumar Pal, please unmute your mic and please ask your question if you have any doubt more. Sanjay Kumar Pal, are you there?
Maybe.
Please unmute your mic. Sir is giving answer to your question. Sanjay Kumar Pal, sir, please unmute your mic.
Yeah. See here, like these
Hello.
are Sanjeev.
Hello,
Can you?
sir.
Sanjeev, can you hear me?
Hello. Yes, sir. I am here.
Yeah.
Sir,
Okay.
you have already given 2 references. One is the 2003.
Yeah, yeah, yeah.
One paper, 2 paper is given. So
This is the just brief. I just want to cite it. I don't want, because they have the first paper, they have used it. That's why they have. I have cited it. There are much more. There are many more. Not much. Many
okay.
more algorithms which uses machine learning in technique in intuition detect.
Okay, sir. Can you give the latest one so that I can go through it and
Yeah. I can share
will
with you. If you can contact me, I can share with you. Right now,
oh,
I did not keep the track.
okay, sir. Thank you very much.
Anyone has any other questions? If you have questions, so you can put it into the chat box or in the question answer.
Participants are requested to kindly post their question in the chat box or in the question answer section. If you have any questions and you want to know any information, kindly post it. We are in the question answer session.
Hello. So if anyone don't have any questions, then I should try to conclude the session. If anyone, we are just waiting for 2 to 3 minutes. Okay, I think one question has come. No.
Thank you, sir.
Okay. Okay. Thank you, Dr. Rajendra ji, for your wonderful and illuminating lectures. Okay, on behalf of the organizing committee, I thank you very much. Okay, for your wonderful lecture.
Thank you, sir. Thank you very much for inviting me also. I am very privileged and I'm honored to accept your request. Yeah.
Thank you all. No, I am not getting it.
Sir, can you hear me, Santanu-ji?
Yes, sir, we can hear you, sir. Santanu, sir?
Santanu-ji, sir, is there?
Kausik, sir, are you able to hear us?
Yeah. I'm here. That is Shantanu Padiga sir here also? Or we have lost him?
Yeah, Shantanu, sir, is there.
I think he has been
Some audio problem is there, sir.
Yeah, some audio problem.
Santanu, sir, we are not able to hear your voice, sir.
Okay, then we'll
Thank
conclude
you.
the session. Thank you, sir, for joining us. Yeah, thank you, sir, so much for joining us. So with this, we will close this session. Today, the feedback link has already been shared. The participants, please submit your feedback links. And thank you all. We appreciate your presence. And tomorrow we'll be meeting again at 10 in the morning. Thank you.
Thank you very much.
Tomorrow we will be back at 10 a.m. So please take the